In this lesson, we're going to take a look at finding the remaining roots when we've got a complex root that's given to us. Okay, so basically what's happening is we're given that x equals 3 minus I. Okay, well, if x equals 3 minus I, we're actually given two roots at once. It's kind of a two-for-one deal. Whenever you have an I, we want to recall that I is the square root of a negative 1. Well, if you have a negative I, all i's are plus or minus because all square roots are plus or minus. Okay, which means I actually am given also that x equals 3 plus I. Okay, so what that means is I can use that information to reduce this problem utilizing synthetic division. So I'm going to first start by using this root of 3 minus I in synthetic division to break up or factor this polynomial like I did in the last lesson. So I'm going to take my coefficients, the 1, the negative 8, the 22, and the negative 20. And I'm going to use synthetic division to reduce this or to simplify it. So I bring down the 1, I multiply 3 minus I, and then I go ahead and add the negative 8. So that's going to give me negative 5 minus I. Now here's where it gets a little complicated. You got to take your negative 5 minus I and times it by 3 minus I. So I'm going to do that off to the side. 3 minus I times negative 5 minus I. And to do that, I'm going to get negative 15. Distribute here, I'm going to get negative 3I, positive 5I. And then negative times negative I will give me positive I squared. Okay, and we want to recall that positive I squared is actually negative 1. If I combine these, this will give me 2I, and I bring down my negative 15. So that means this will actually result in negative 16 plus 2I. Okay, so that's going to go right here, 16, oops, sorry, not 12, 16 plus 2I, and it's negative 16. Okay, and now we go ahead and combine these two, and that's going to give me 22 minus 16, which is 6, plus 2I. Now I take my 6 plus 2I, and I have to actually find the product of it and my 3 minus I. So 6 plus 2I, I'm going to go ahead and erase this stuff over on the left, and replace it with a 6 plus 2I. So now I need a FOIL. 3 times 6 is going to give me 18. 3 times 2I is going to give me positive 6I. Negative I times 6 is going to give me negative 6I. And then negative I times 2I is going to give me negative 2I squared. Now, the 6I and the negative 6I cross out, and I'm going to get 18 minus 2 times negative 1. This is really negative 1 right here. So that's going to give me positive 2. So this equals 20. So that goes right here. It's 20. And these 20s cancel, and you have a remainder of 0, which you should. And I have to have a remainder of 0 because they said 3 minus I is a 0. So if I came up with any other number right here, I'd have an issue, and it wouldn't have been factored properly or divided properly using synthetic division. So now let me erase this side work over here, because I want to recognize that there's a 1 right here, this negative 5 minus I, and then the 6 plus 2I are my factors that are left. Okay, they're actually my coefficients that are left. So really, this would be x to the 0 power, x to the first power, and x to the second power. But that's really awkward, and I don't even need to write that, because what I'm trying to get to is my next step of synthetic division. Because I know that 3 minus I went in evenly. I want to now take these coefficients, the I, the negative 5 minus I, and the 6 plus 2I, as my coefficients, and I want to actually do synthetic division now with 3 plus I. Because again, let's go back up, where we saw that, or I said that, we have 3 minus I is the root that was given, and it automatically comes with a 3 plus I as a leftover, a secondary 0. Okay, and we're trying to find all the zeros. So since I know it's a 0, I can go ahead and do synthetic division again to see if I can have a better looking polynomial left over that I can maybe factor and find further zeros. Okay, so we're going to do synthetic division again and bring down the 1. So that's going to be 1 times by 3 plus I. And this one, the i's cancel. That's nice. Okay, and I get negative 2. Okay, so now I just have to take negative 2 and times it by 3 and the I, which is going to give me 6, negative 6, sorry, minus 2I, which is wonderful because this turns into a 0, which it had to because, again, I said this is definitely a root, so if it is a root for sure, in other words, it is a 0, it should have a remainder of 0. So what that's left over with is a negative 2 and a 1 as coefficients, where this is x to the 0 power, this is x to the first power. So what that means is I'm left with one factor of x minus 2. Now, since that's a factor, what that means is I have other factors, two others actually. I have well, they might be confusing, but I have x minus 3 plus I, and then I actually have another factor of x minus 3 minus I. But again, don't be worried about that part. What we do want to worry about is the fact that I need to set each of these equal to 0 to get my roots. Well, I already have these ones. I need to have x minus 2. This final answer gets set equal to 0, and that gives me x equals 2. Okay, so the final roots that I would put into the lab are 2 and my 3 plus I, and I was given 3 minus I, so I don't need to write that in there as my other root. I need to write this one in there and the 2. Okay, so again, back to the beginning. I know this is a hard problem, but try to follow. I'm going to recap. I was given 3 minus I. I do synthetic division with that, and I know that's a long process, but you have to make sure that when you do synthetic division, you'll know you did it right if you get a 0 over on the right-hand side, because it should have gone in evenly because it says it's a 0. It means you'll get a 0 there. Then, whatever this number was right here, change the sign in the middle to be 3 plus I, or whatever your number is on the lab, to put a plus I there. So just if it was a plus sign, so like if this one was originally a plus sign, you would change it to be a minus sign in a second. Whatever it is, do the opposite just in the middle. Then do synthetic division again. Because I'm telling you that this will be a 0, it needs to become a 0 right here in the root, or as a remainder. And then we backfill our coefficients, and we're left with our last factor. Set it equal to 0, and then solve for x. And that's how we get the final third solution.